Okay, Dan, it's 3 o'clock. We are live and you are good.
All set. All right. Go ahead and get started, I guess. I can figure things out. Um, uh, for those of you that don't know me, my name's Dan Kulp. I've been involved with X-Lights and FPP for, I don't know, a very long time. I don't want to say all the way back to the beginning because it's not that far, but it's like 6 or 7 years. I was back when X-Lights was still 3.0 and it was like little 2-column things. I was doing stuff there, and then kind of got involved with some of the FPP stuff at the same time. So call me an old fart or something. I don't know. I don't care. But basically, that's kind of how I got started. Was just doing some stuff. I actually started with the Hinkle light sequencer thing, and I got started with X-Lights to write the conversion to convert those over to sequence files to play on the FPP, and then so I kind of got involved with FPP, and it's just all kinds of stuff there. So been around for a while, and obviously have made a lot of contributions and stuff to the various stuff since then. So this presentation is specifically about the controllers that I have designed mostly for my own show. Many years ago, and I'm going to get a little bit of history here in a little bit, but Dave Pitts kind of designed the first BeagleBone controller, and I liked it a lot, and so I kind of got involved with the PRU code and like the low level stuff, which I'll kind of talk about a little bit, and from there I just kind of decided to design my own because that had a little bit more outputs and stuff, and then I just kind of grew from there. So what this presentation is really about the whole suite of controllers that I now have, and a little bit about why I created them and what their capabilities are and things like that. So, so again, I'll talk about the history and the various types of capes and stuff. So again, pretty much all my controllers are based on BeagleBones. For those of you that are not familiar with the BeagleBones, they are very similar to the Pi. If you're familiar with a Raspberry Pi, using a BeagleBone is pretty much not really any different. You install FPP pretty much the same way. It pretty much performs roughly the same. That said, I mean, they are a much older device. I mean, they were from 2012, I think, is when they came out, or 13, something like that. So whereas obviously the newer Pi 3s and Pi 4s are much newer than that. So they're the new Pis are a little bit faster from a ARM core side. So these are basically a single core with half a gig of RAM and USB and all that stuff that you kind of expect, kind of very similar to the Pis. One of the main difference between the Beagles and the Pis is the number of GPIO pins. And if you can kind of see, you have on the full-size Beagles, you have 2 rows of pins on either side that provide a lot of access to GPIOs. And on the Pocket Beagle, you have the not as many pins, but there's still a lot there, and significantly more than what you have on a Pi. I think the Pi you only get like 22 or something pins that you get to use, and they're kind of restricted. Whereas on the Beagles, the full-size Beagles, we use 55. If we turned off the EMCC, we could actually get another 10 if we wanted to. So there's a lot of capability there that we have access to. The other thing about the Beagles is they have lots of things that we didn't even start using till recently. There's the full-size Beagle have 7 analog to digital pins, which I'm now using to read voltages and temperatures and things like that, which the original FPP for the Beagles didn't even kind of know about them. So like I said, I like the Beagles a lot. There's a lot of capability there. We're still kind of finding more things for them. But the real reason why my controllers kind of need the Beagle is the programmable real-time units, or PRUs. These are basically, it's a 200 megahertz dual core processor embedded in the processor. So each of these cores has its own little dedicated RAM, its own instruction like cache and basically its own resources. It has some direct access to GPIOs, but for the most part, with the amount of GPIOs we need, we kind of go through the main bus to the memory locations. But that's the big thing here is the way the PRUs are connected in the Beagle is they have full access to everything in the BeagleBone. So they have access to the full 100, like half a gig of RAM. They have access to all the GPIOs. They have access to UARTs if they need to do debugging or whatever. They've got a lot of stuff that they have access to. Now, and that said, a lot of the Linux kernel programmers hate this because if there's I want to say a virus or something can load onto the PRU, they can read all the RAM and do whatever. But for what we need to do, it works perfectly. These PRUs are completely separate from the ARM core. If we go back to that slide, there's the single core. It's an ARM Cortex A8. The ARM core is what we use to run FPP. It handles the Ethernet and the sound and pretty much the web interface. It handles all the except the networking, the formatting of the pixels and things like that. But then we hand the data off to the PRUs to actually output the data to the pixels. And because these things are completely separate from the main ARM thing, anything that goes on the ARM doesn't interrupt these things. So if an interrupt like a network packet comes in and triggers an interrupt, the main CPU, because it is a single core, would have to stop what it's doing and process that packet, which when you're trying to output pixels, you can't have that happen because like the WS2811 protocol is extremely timing sensitive. And if you don't get the timing exactly correct, your pixels are not going to work. They're just going to stop or you're going to get like flashes and all kinds of weird things going on. And obviously you don't want that to happen. So these cores, these PRU cores, can continue to send data out on the GPIO pins without having to worry about what's going on the main core. Now, if you look at a traditional controller like the Falcon or the Hinks or whatever, the AlphaPix, they generally do this in a very kind of similar way. They usually have a one core, like probably an ARM core, it might not be, that handles the web interface and something like that. And then they send the data off to like an FPGA or something similar to that to actually do the output of the pixels. The BeagleBone is nice because it's all kind of integrated onto a single package that can be used. So yeah, that's a little bit about why I like them. They're kind of cool. A little bit of the history. So this kind of goes back quite a ways. Back in 2013, shortly after the BeagleBones were released, it was probably still just the BeagleBone, the original BeagleBone, and not even the BeagleBone Black. Some random person created a PRU library for driving P10 panels from the GPIO pins. It was very PRU driven, so they were able to drive, I think, 64 panels, and this is where the first octo scroller kind of came from. Shortly after that, the same person got some contributions, and they were able to add some PRU code to do some WS2811 into the same library. So using that library, they were able to kind of drive various types of pixel things. And then in 2015, kind of Dave Pitts discovered all this kind of cool libraries, and along with Chris and a few others, he basically came up with the very first, or added the code for the Leadscape stuff right into FPP, and kind of designed two capes for the BeagleBone that use the code to drive pixels. So the original F4B and the original F16B from Dave Pitts were in this time frame. As part of that, at the time, PixelNet was kind of popular. Most people in this presentation probably don't even know what PixelNet is. Kind of went out of favor several years ago, but Dave also worked some of his magic and added DMX and PixelNet code into the PRU code for Netscape, for the Leadscape, and again, the F16B and the F4B, they were awesome boards. That's kind of how I got involved. I bought, I think, 2 of the F16s and 2 of the F4s. They were kind of kits that you kind of had to assemble yourself for all you DIY people. That was back in August 2015. And I used them in my show for several years, actually. I really liked them. In 2016, not a whole lot happened. Obviously, a lot of things kind of happened for Chris and Dave and stuff, and life happens. Things like that. And Dave kind of moved on to the F16B1, which is obviously an awesome board, and it was definitely the right decision for him. There were some reputation issues around Beagles freezing. Especially for those in like Denver and Canada and stuff, it would just kind of lock up, and that turned out it was a kernel issue, Linux kernel issue, to some extent. But again, we just didn't know it at the time, so there was some reputation issues, which is one of the reasons why Dave moved on. But then in 2017, I kind of outgrew my F4Bs. I used several of them in my display, and the 4 outputs was not enough. And so I kind of needed more, but they were kind of all gone because the group buy was like 2 years previous and kind of hard. So I contacted Dave, and he actually gave me all the schematics for the F4s and the F16s. And he really helped me. I don't have an electrical engineering background. My background is actually chemical engineering. I have a degree in chemical engineering and computer science. So a lot of what he was giving me as far as information was really new to me. It was very, I'd never done like a whole lot of circuit design type stuff. So it was, he was a huge help, which to his credit, Dave's a great guy. And he basically, I was creating boards that would kind of compete with him, yet he was still able to and willing to help me out and help me learn and stuff. So he definitely deserved a lot of credit for that. So I kind of designed the original F8B because like I said, this was for my own show. So I needed something that had a little bit more than 4, as well as my Mega Tree. I needed 18 outputs instead of 16. So I designed the original F32. And since I was ordering them from China and wanted them for myself, I decided to offer up a group buy in 2017. And because if anybody knows, if you order anything from China, it's like $500 for 5, but like $600 for like 50 of them, or like it's ridiculous the way they scale up. So if you buy like 20 of them or 30 of them and then sell the rest, it kind of works much better. So I did a group buy. It was, let me just say that the group buy was relatively disappointing from some standpoints. I only sold 3 of the F32s. I thought they were going to be awesome, but nobody really bought them. But in order to support that, this is when I really started getting involved with FPP, was because I needed to get all of or FPP2 out to support the new pinouts and stuff that were on these boards. So that's when I really got involved with FPP and created new images. I did a lot of hand tuning of the PRU assembly code and stuff like that. So that was that year. 2018, the Pocket Beagles were introduced. So I kind of thought, well, maybe by going with Pocket Beagles, we can get some new ideas and new stuff, maybe sell some new things. So I did another group buy. Again, the group buy did better. I wouldn't say I sold a lot, but it was at least a little bit more promising. And finally, we released the 2.0 version of FPP, which was a huge upgrade from 1 because we went from Wheezy to Stretch, which we basically skipped Jesse, which was in the middle there. And it was just a big upgrade. There's all kinds of functionality that was added, and just getting things ready to move forward with what eventually became 3 and now 4. So that was a big year for Beagles and FPP. Last year was a huge year, huge year. I designed a whole bunch of stuff. This is when I started really looking into what the Beagles offer. As I mentioned before, the previous designs were all around just the PRU stuff. When you start looking at the Beagles, you realize there's I2C bus, there's the analog pins, there's all kinds of stuff there. You can use the GPIs to do different things. You can, there's sensors and push buttons and all kinds of stuff. So I spent a lot of time looking into adding code into FPP to support various things, and then designing upgrades or updates to all of my boards to actually use these things. So like my boards all now have OLED displays and temperature sensors and push buttons and stuff that came out of all that work that was done for that. And again, because I have all these boards that now have OLEDs and sensors and push buttons, we needed a new version of FPP that supported all that stuff. So that's when FPP 3 was released specifically to support all those new features. And this was now Buster based. So for those of you that are not familiar with Linux, for Linux Debian, they use characters from Toy Story for their names of their releases. So like Wheezy, Stretch, Wheezy, Jesse, Stretch, Buster. I don't know what the next one's going to be. That'll be next year. The group buy for this went much better. I want to give a huge shout out to Wired Watts because they recognize the value. Ken did a wonderful and basically pre-ordered a bunch, basically sight unseen, which basically helped me make the cost of running the group buy much more palatable. And I was able to use some of that to set up Kulp lights and set up my own store and stuff like that, and offer these things more. Because previously it was just, okay, I'd buy a bunch as part of the group buy, and then I just sell periodically if anybody asked for them throughout the year. And now that I have a store that people can actually go to and purchase them. So, and so the group buy last year went really well. And thanks to everybody that bought them, by the way. That was, thanks. So there's basically, going forward, there are two different categories of capes that I offer, and that are basically used on the Beagles. The first kind of cape, again, it goes all the way back to the original capes, is the Octoscroller. There's a bunch of different vendors have different versions of them. I know like Alan has the Octa scroller, which is basically an Octa scroller with an RT real-time clock on it, and I believe even JBoards has one with I'm not really sure. I don't. So a bunch of different vendors have them. They've been around for a long time. I did create an Octo Plus, which is basically an Octo scroller, slightly different pinout for a variety of reasons. But adds the OLED and the temperature sensor and the RTC and push buttons and things like that. I mean, it's obviously, I want to say it's kind of a premium product compared to the base Octo scroller because it does offer a lot more features. So it does cost a little bit more. So if you're being cost sensitive, then order an Octo scroller from somebody. They're great boards. They're, like I said, and they're available from several different vendors. Also designed the Pocket Scroller, which is basically a Pocket Beagle based version of the Octo. Because the Pocket Beagle has less GPIO pins, I can only support 6 outputs instead of 8. But for things like Tune2 signs and smaller displays, you don't need 8 outputs. Most likely you don't even need 6, but the Pocket Scroller is there as a smaller option for those types of situations. The panel capes, they do use the PRUs to drive tons of data. They, just as I mentioned before, the CPU can be used to load the F-sequence files and do all the networking stuff, and then that leaves the PRUs to output all of the data. It is now all hand-tuned PRU assembly, which kind of allowed the Leadscape code. By abandoning Leadscape, we were able to increase the number of panels that we output, reduce the flicker by a lot, faster refresh. We were able to go up to 12-bit color in some cases. So for the most part, these over the years, the panel capabilities have gone significantly better. I don't want to say we're at color light level yet. I mean, if like real video type output as far as like running I don't know, like flesh tones and those types of things are important. I mean, the color light's still a better option. But what they're able to do now is I want to say like 95% of there, but it's also significantly easier to set up. The color lights can be very complex to set up. Obviously, you need a Windows box to set up color light stuff, which if you're a Mac user, that's kind of a problem. But like I said, it's easier to set up, and you get pretty close. But it also cannot run quite as much as a color. The color lights, you can do these gigantic panels, but for 2 signs and stuff, it's perfect, but also much better than using a Pi. Because one of the problems I mentioned before is the Pi uses its main cores for this. So if a network packet comes in and the core interrupts to process that, then the data that's going out the timing may be different, and you get a lot more flicker. So running panels off of a Pi, in some cases, you'll see a lot more flicker than you would with a Beagle with using the PRUs. So again, I recommend them over the Pis, unless you're going to use the Pi to drive a color light. So like, as I mentioned, I offer 2 of them for driving panels. We have the Octo Plus. It's Beagle based. It's got 8 outputs with the temperature sensors and all that stuff. So that's the top one there. The Pocket Scroller is the smaller version. It's got 6 outputs. It's got the OLED. It's got 2 little buttons and a temperature sensor. How that said, because of the lack of output pins, if you use the OLED and have it enabled, then you only get 5 outputs instead of 6. But again, if you, in a lot of cases, 5 outputs, you can run 6 P5 panels off of each output. So I mean, that still gives you 30 panels of output of driving capabilities, which is a significantly sized display. So still very capable. So the other type of panel of controllers that are the string controllers. The way the PRU code works is they can only drive the WS2811 and fully compatible pixels, and that's very important. The way the PRUs work, it's all of the strings pretty much have to be exactly the same. I mean, I could technically write separate PRU code for different types of three-wire pixels, but again, all 48 strings would have to be identical. So it just made sense to just concentrate on the 2811 and work with that. So that's the main, I want to say, restriction that we have between the Beagle-based capes and like the Falcon or the Hinks or anything like that, or the Alpha Pix and things, is this exactly. I can only drive a single type of pixels, whereas if you have pixels that are uses one of the other chips, they're not going to work. And I'll be right up front and tell you they're just not going to work. But that said, pretty much most of the pixels you buy nowadays are the 2811 timing. So it's not usually a problem. Some of the capes, the original F8, the original F16s, F4s, and my original designs did allow one PRU to drive like one of the RJ45 things to output either 4 or 8 DMX universes, or 4 universes or 4 or 8 universes of PixelNet for those using PixelNet. The problem with that is when it was a little bit strange to configure, and obviously you lose one of the RJ45s, and with DMX not being used as much now, it didn't make sense to lose one of the RJ45s that could be used for a receiver, the differential receiver. So my newer boards this year, I'm actually discovered that the onboard BeagleBone UARTs work fairly well, really well. So the newer capes actually use the dedicated UARTs, so all the RJ45s can be used, and thus the newer boards only have 1 or 2 DMX outputs. But again, DMX isn't used nearly as much as it was 4 or 5 years ago. Again, in this hobby, things change quick. So what was perfect 3 or 4 years ago, maybe not so much nowadays. The current PRU code that we use is set up to drive 48 string outputs. If I ever decide to go and make a board that uses more of the BeagleBone pins, we could probably change that. But at this point, 48 seems to be fairly reasonable. Because it's not multiplexed, we get the full, all 48 strings gets the full number of pixels. So at 20 frames per second, you get 16, because it's limited by the WS2811 protocol, you will get 1600 pixels, which is on each string, or so on all 48 string. It's a lot of pixels. I don't recommend that, because obviously if one pixel goes out, I mean, that's a lot of lights that go out. But you could do it. At 40 frames per second, you're down to 800. Again, this, I should mention this is with FPP 401, older, basically FPP3, the numbers were slightly about 10% lower, 10 to 15% lower. We did tighten the timing up a little bit. But yeah, a lot of pixels. These aren't banked, so even if you add more expansions or whatever, it's still 800 pixels at 40 frames per second on all of the strings, which again, it's a lot of pixels. Thanks to FPP and the work that was put into FPP, all the strings support virtual strings, and all of your normal like zigzags and null pixels and brightness and gammas and all that fun stuff that you kind of expect from a high level controller. And part of 3. I don't know, it's like 3.3 or something like that. We added support for the Falcon Smart Receiver Protocol. So if you have the Falcon Smart receivers, and one of my boards that actually has the RJ45s, which I'll get in a second, you can plug them in and you can configure them like A, B, C, and one of the strengths again is because we don't have banks. That's the full 800 pixels across the 3 receivers, so you can run 200 pixels on each of the receiver boards on every single port. I like the smart receivers. They work very well. It was a very good idea from Dave, and he did a good job on those. And I should mention that this is the biggest disappointment I have from not having the Christmas Expo this year, was the code, or the reason why FPP supports the Falcon Smart Receiver Protocol now was because at the Christmas Expo last year, I was able to sit down and have dinner with Dave Pitts and discuss this protocol, and talk with him about a lot about it, about what was going on with them. And then I came home, and within a few days, I had it working. And that was a very valuable experience last year. So, and again, Dave was more than happy to talk about it. Dave's great. So the boards that I offer, we'll start off with the Pocket Beagle based boards. I have 3 of them currently. The first Pocket Beagle one was the F8PB. That's the one over the top right there. It has 8 local outputs for 8 strings that are fused. That board, it's 30 amps on the incoming connector, and each string can. It comes with 5 amp fuses. Technically, the traces on the board will allow you to go up to 9 amps. So if you need one string that needs a little bit more, you can swap the fuse out for a 7 amp and be safe. That said, don't exceed the 30 or you'll melt down the connector to the power supply. So don't, just be careful of that. Hate to recommend that, but just thought I'd mention it. It does have then 3 RJ45 for driving differential receivers. And again, they can do the smart receivers or the dumb receivers. And then basically a 40-pin connector on the one edge there that you can grab a Falcon expansion board. So whether it's a regular string expansion or another differential expansion, you can then get another 16 strings off of it. So you can start off with something small, like with 8 strings, and then as you need more, you can get smart receivers or differential receivers or the expansion board, and kind of grow as you kind of go into it. They does have an OLED. The picture doesn't display it there, but there's an OLED that can be stuck on it. It's got an RTC to keep the clock, temperature and voltage sensors, so you can kind of understand what's going on with them. The original KPBs that I've been selling, 2 of those RGB 45s could be swapped or set to drive up to 8 universes of DMX. The K8 PB, which I'm hoping to get in the next 2 weeks. They're supposed to be manufactured last week, but and shipped soon. But they're going to be slightly different in that there will be a dedicated pins for DMX. So there'll be a single kind of dedicated DMX output, and then so that all 3 of the differential ports can be used for driving strings and still have a single DMX type thing. So that's coming. But again, the current version has enough there. The K4, this is my newest one. I was using this for testing a few things. It's a very small one. It's designed to fit into a TA200 box. It's a tiny little box. It's basically the same size as a differential receiver. And it actually uses the same mounting holes and stuff. So you can actually, if you have a place that has 4 strings based on a differential thing, you can kind of plop this thing in there and configure it as a remote and get rid of the Cat5 cable. So that's kind of what it's designed for. Obviously, fitting it into a small box with a Wi-Fi adapter means you need to use one of the nano Wi-Fi adapters that doesn't have the big antenna and all that stuff. So there are restrictions with that, but it's a really small controller specifically designed for basically someplace where you just need a small number of outputs. And then finally, I have the K40D PB, and that's got, this is all differential outputs. So it's very similar to the Falcon F48 in that it's all differential, and you need to then buy a whole bunch of the differential receiver boards from someplace and basically use those and run Cat5 cable all over the place. I mean, this, to be honest, this is something I'm not exactly sure why this is not something I'd run in my show, because I don't use Cat5 cable in my show at all. So this is one of those things where I kind of designed just for the fun of designing it, and then decided to offer it for sale and see if anybody was going to buy it, which they are. So the K40 is a little bit different than the older F40 that I offered last year, and the same thing that there's a 3-pin dedicated DMX off to the side, as opposed to tying up some of the RJ45s for that. So, but other than that, they're pretty much the same. So if you have the older F40, there's not really much difference. So, oh yeah, quick thing. The RTC is a real-time clock. Most of my boards, the K4 is the main one that does not have a clock on it. For a couple of reasons, but basically they all have a clock on them, so they can kind of keep track of the clock if they don't have internet access. That said, I generally recommend just having internet access, and they can pull the time as needed. Or if they're running in remote mode, they don't even need to know what the time is, because the master just will tell them what to do when. Any other quick? Oh, all right. So going to the full-size Beagles, again, I have 3 string capes. We have the F8. This was the original boards. I once, a few weeks ago, was asked which was my favorite, and this kind of falls into that because it's an evolution of the very first board I designed. And as I mentioned, this isn't really my background, so I don't know a lot about the whole electrical engineering. So there's a soft spot to me on this one because it was my first experience designing a board and getting many things manufactured and ordering PCBs and all that stuff. So it was kind of a good learning experience. And it's pretty much the same as the F8 PB. Same basic functionality. It's just using the full-size Beagle instead of the smaller Beagle. Really not much to say other than that. It's obviously using the full-size Beagle. It's got the Ethernet built in, whereas with the Pocket Beagle, you need to use a USB Ethernet of some sort. But other than that, they're pretty much the same. And so when people ask, hey, which would you prefer? Like which do you recommend or whatever? It's really whatever you feel like doing. I mean, the F8 B is a little bit harder to mount because of the way that the Beagle's underneath, whereas on the Beagle, the Pocket Beagle one, it's more traditionally flat. But it's just 6 of one, half dozen of others. It's not a big thing. Shoot, the picture's kind of over kind of going over some of the text, but that's okay. The newer ones this year are the K16 and the K32AB. The A means that there's audio on board, which I'll come back to in a second. The 16 is basically 16 local outputs. It's got the 4 RJ45s for the differential receivers, and then it's got the 40-pin connector for an expansion board. So if you could start with a 16, and just like the Falcon V3s, you can buy one of the expansion boards from Falcon and plug it right in there and get another 16. So again, you can start with something smaller, something cheaper, and in 2 years, if you need to grow a little bit more, plug a little bit more stuff in there. It does have 2 dedicated DMX ports if you need them. And except the big new thing for this year was the audio support. There's a high quality DAC on board, so the Beagles actually have the ability to process the audio directly, and there's a special what's called an MCASP, MCASP set of pins. Multi-channel audio signal processing is built into the Beagle chip. So that gets sent off to the DAC, which then can output to the audio to the port. And then there's a header there for actually plugging an FM transmitter directly onto the board. So you can actually have completely standalone capabilities with the F16 or the K16 and the K32s. They both offer that, and it's kind of new this year, and took quite a bit of work to get working, but it's kind of there and kind of cool. The only real difference between the 16 and the 32 is the 32 replaces that 40-pin expansion with another 16 local ports. That's really about the only difference. The shape is a little bit different because once you add that space up there, trying to get to the USB port or the SD card is going to be even more difficult. So I had to kind of put a notch there to try and get to them. But it's the other option, which I also recommend, would be there's special cables that I actually sell in my store that will extend the SD card out or the USB out, and I do recommend those if you need those. So that's those boards. The other thing that's new on these boards, and I didn't even mention, is there's for the 16 and the 32, there's these 16-pin GPIO expansion, which provides access to the I2C bus as well as a bunch of GPIO pins. So if you want push button triggers, or there's the servo controllers that connect to the I2C bus. You can connect to those very easily and use that capability right of FPP to have local triggers. And this is one of the things that's very different with using my boards, especially with the sound on them. It's like you could have, if say like the K16 was driving some prop near the street, and you want it so that when a proximity sensor triggers, that a scream is heard, like this is a Halloween thing, or like a thing that pops up and goes boo or something like that. That can be done completely locally because you can wire the sensor into these GPIO pins, and then once it triggers in FPP, you can configure it to have a scream that then plays on a speaker connected to this audio output, and it would be very localized. So it wouldn't be going out across like the FM, like your main show sound. It would be localized to just what that person like right near where it was triggered and stuff like that. So it's not like the people sitting out in their car watching the show are suddenly gonna hear a scream and go, okay, well, where did that come from? And it's very localized. And that's part of what the FPP system and my boards are intended is more instead of having like a central show area that kind of goes out to all the pixels, they're designed more to have the right size controller for the various props spread throughout your yard, and being able to configure each one individually and be able to do different things on each one that may not affect what's going on the others as well. And that's part of what the whole FPP system gives us that we don't have from before. So I have, what, 10 minutes left. The other type of cape, I'm just going to mention these quickly. These were kind of a joke, kind of. I needed a way to flash the EEPROMs on my other boards, so I kind of created this little board to sit on the Beagle to allow me to flash stuff. And I showed it to a couple of people, and like, that's kind of cool. So why don't you make one of them? And then so I designed the Pi OLED, and I offered them for sale, and apparently people like them. They don't really do anything like other than provide you some information on a display, but I do offer them. They're kind of cool to some people. So going quickly, just to finish up so we have time for questions. There are advantages and disadvantages. I've mentioned before, main advantage is there's lots and lots of WS2811 pixels. Disadvantage, it's only the WS2811 pixels. You get a lot of them, but you very restricted as far as what the strings can do. On the panel capes, we get lots of panels, good colors, stuff like that. Better than a pure Pi driven panels, but not quite as good as a color light. I'll admit that, but it's easier to set up. They're inexpensive. My boards are generally a bit cheaper than like the Hinks or the Falcons or something like that. I mean, the Falcons are great boards. And again, Dave's great. I don't like the fact that I'm taking some business away from him. In some ways, it kind of bothers me a little bit. But again, Dave's been very supportive of me as well. And he and I have a good relationship and stuff. So there's no, as far as I know, there's no real problem there. But because there's Beagles and all kinds of weird, a lot of stuff going on these boards, there are some concerns with reliability because like Beagles you can fry the Beagles if things happen. And that said, because it is a little bit more modular, if you fry a Beagle, you can just you can kind of swap out the Beagle and the board is still good, and vice versa. Like if you burn up the connectors on like the power connector, you might be able to save the Beagle itself. FPP, this is one of those things where it is, because it's FPP based, that is a very, very huge advantage compared to some of the other boards. However, it's also its biggest disadvantage. And I will be completely honest on that. FPP is extremely powerful. It can do all kinds of stuff that none of the other controllers can do. But because of that power, it's very complex. There's more of a learning curve. If you're a beginning user that has never used a controller before, expect to spend more time learning how to use FPP based controllers than you would like a Falcon or something like that. The FPP4 helps a lot. I mean, there's a lot of stuff that we did in 4 to make things a lot easier, but at the end of the day, they're still very complex. But like I said, FPP, you have full Wi-Fi, you have the master remote and bridge modes all available to you. You have sound outputs, you have overlay models, which I'm going to get to in my next presentation. You have all the GPIO triggers. Because I provide access to the I2C bus, you can run servos as well. If you get the little cheap, they're like $10, or not even $10, like $10 for 2 of them, of the servo control modules that work on the I2C bus. So that's built into FPP. There's all kinds of stuff that you can do with FPP based controllers that you just can't do with some of the other controllers. The Home Assistant stuff that Chris did is awesome. And I will be covering some of that in my next presentation as well in 15 minutes. And so like I said, there's just all kinds of stuff that you can do with FPP that you just can't really do. So to me, having that extra power kind of overrides the disadvantage of all that complexity. And again, the X-Lights integration for the X-Lights users is just phenomenal. There's just a lot there. The FPP Connect is improving as time goes on as well. So that's pretty much the information I wanted to present about my boards. We have obviously questions. I'm going to see what we can have here. We have about 5 minutes or 10 minutes. So let's see. If anybody has questions, feel free to unmute or whatever. So let me scroll back here. All right, so I answered the RTC is the real-time clock. Again, my boards support them. Again, master remote, really the master is the only one that really needs it. And obviously if you're running in bridge mode, again, they're not really needed, but it's nice when you kind of go to the controller and it actually displays the right time. I guess it's my OCD kicking in or something like that, but it's just having the right time there is kind of a good thing. Let's see, when are they going to be available on my site? I kind of covered that. The 16 and 32s I have now. The 40s I have plenty of. The Pi OLEDs and the BB OLEDs I have. The 8s are on order, and I have more 8s and more 4s on order. And again, they were supposed to be manufactured last week and this week, and shipping soon. So probably in a few weeks I should have a bunch. Again, I need to mention Wired Watts and Ken sells all of these things as well. And if you need things other than just the controller, like if you need strings to go along with them, I think Ken also sells the differential receiver boards from Dave. So if you need more like out of the box everything you need to get going, Wired Watts has all the stuff in stock as well, roughly the same stock as well. So he definitely consider that as well. Let's see, keep going. The Piola hat is cool, which is interesting. Yeah, the GCs, no, like I said, WS2811s only. Covered the KB.
Dan, with the stuff moving to Ks now, and I think you mentioned you're going to do a K8 to replace the F8. Are the new 8s coming in F8s, or are they going to be K8s?
K8s without the audio. I mean, they will not. They will be a K8B, K8PB, so not the A dash. So, but again, the onboard audio is kind of useful, and with any of my controllers, because they are FPP based and they have USB ports, even if you have an older version that doesn't have the audio, it's not hard to add. I mean, you can get a USB hub if you need it. If you have the Ethernet based stuff, you may not even need the hub, and a $20 Sound Blaster card, and you have really good audio available from any of my boards. So just because the audio is built on the newer boards, it's somewhat of an advantage, but it's not a huge like earth-shattering type thing. So real-time clock. The color versions of the Falcon expansion boards, it's really just the whites out of the box, the newer V3 expansion boards. The red ones can work, but you need to cut one of the pins on the cable. I can't remember which one. I want to say it's either the 2 or the 4 pin wire. I'd have to look that up. But for the most part, if you're buying a board now, it's going to be the white ones anyway. But if you have a red one that you need to use, it's just a matter of cutting one of the pins on the cable and it'll work. We don't daisy chain. It's a single, I know like the Falcons, the way they do the banking, you can put 2 expansion boards on the one port, which I don't do because I don't do the multiplexing. So it's just a single expansion board. We had a question about that on the Facebook forums this last week.
You also support the blue expansion board, that be the V1 board?
I don't think so. I don't know anything about those. So I don't know if they were different between the blue and the red, or like I've never even seen one. So I don't know.
Okay. All right.
I don't know. It does, like I was mentioning, yeah, the full string lengths on all the ports, including the expansion ports. The FM transmitter that I have, it doesn't come with any antenna at all. There's just a little solder point on there that you need to solder some sort of antenna on there. It can be something as simple as like a 75 centimeter wire, or you can do something more complex off to a dipole or something like that. So again, it doesn't have anything there. That's the one thing that I want to say is DIY, is you need to figure out how to attach an antenna. Not too complex, I think. Hopefully most people can handle that. Keep scrolling. Let's see, anything else? Again, the nice thing is that all the triggers and stuff that you have in FPP and the GPIO expansion. So yeah, haunted houses and things are kind of neat. A bunch of you guys were answering questions while I was talking, which is great. Thank you. A lot of good help there. At this point, there's a question here about the I2C temperature sensors on the Pis. And this is something Chris and I have talked about. There's currently not a way to configure other I2C devices. Right now, it's all done. There's a little program that when FPP boots up, it runs and it reads information off the EEPROM, and the EEPROM will tell FPP, okay, there's this sensor here, this sensor there, and the string configuration, like what GPIO pins match. So all that stuff is read off the EEPROM, and currently the sensors are only read from that. It's been one of those things where the code supports additional locations. We've just never had the time to create some sort of user interface to actually be able to configure any of those things. So that's something that's been on the to-do list for a while. It's never bubbles up high enough as far as priorities go. Let's keep scrolling down through here. Very much. I think that covers most things. So does anybody else have any other questions? Actually, there's a question here about, or a comment about customer service. And I guess this is something I really need to point out. This is not my day job. For those of you that don't know, I'm actually a VP of open source development for a $1 billion company called Talent. We specialize in big data and all that stuff. So this is not my day job. So I do my best and I try to support, like ship things relatively quickly and things like that. But it's limited as far as what I can do because this is not what I'm paid to do. So again, when I ship things, I pretty much try to ship mostly USPS because the mailman picks them up right here every day. But it may be 2 or 3 days from when you order before I can ship because work may get in the way. But like I said, I try my best. I do obviously read most of the forums and stuff. I respond to emails as much as I can. Particularly in December, I'll try and spend a lot more time. I know last year, I think I spent weeks SSH'd into several people's FPP instances to run FPP in debug mode. So I had windows on my machine, like a window here and window there, just all SSH'd in, just running in debuggers to wait for crashes to try and stabilize things and stuff. So it's all off to the side, but again, it is not my full-time job. Do my best, but sometimes there's a little bit of delays. The volts, all my boards, the K4 currently does not, but the others, the K4s and the 5 volt, so the PIP, the 40 and the Octo pocket scrollers do not. But the other boards do have voltage displays for each of the power connectors, so you can kind of see what voltage is coming in. So that's there. A lot more questions. There's questions about the AC 1200s. The 5 gigahertz Wi-Fi adapters are awesome because they're very fast, but they're very finicky. Things like studs in the walls seem to have problems. So I've discovered, like, I've been using them in my I use them in my display this year for all my controllers, but they were very dependent on where the access point is. If I had the access point too close to the front of my garage, they would all lose connection like randomly. If moving the access point back 5 feet, and they were suddenly rock solid, and they're very, very finicky. But once you get all the right combination correctly, they're very fast, and especially for things like uploading sequences and stuff, which again you don't do very often. But a big thing about the AC 1200s though is they do support access point mode, which is if you need the access point mode for configuring things, they're there. The TTY S1, S2, those are your DMX ports. Those are your UARTs. They're labeled that way because that's what they are labeled in. That's what the BeagleBone and Linux calls them. They're basically serial ports. So that's why they're labeled that way. And if you go to the other tab, which I don't know if I can get out of. I lost my mouse. So again, if you kind of go off to a different, go to the input outputs or outputs. And this is where you would basically configure like a DMX thing. That's the port that we would be selecting right there. So, and then I lost my chat, so I don't know where it went. Anyway, I think we're out of time. We have to do the raffle before the next thing. So I need to stop anyway.
Beautiful. Well, we want to thank you, Dan, for the awesome presentation.
I'm going to stop sharing so that the raffle people can do their thing.
Okay. You guys hear me okay? I'm guessing yes.
Loud and clear.
Sounds fine.
Okay, perfect. Let's go share my screen. Okay, the raffle is from Kulp Boards. It is a $50 gift certificate to his site for any one of them new boards you guys just saw. So I got everyone in here. Let's see who's gonna be the lucky winner.
I want to revote.
Brian Rudy,
Oh man.
1919.
He's in.
Yeah, I'm here.
Awesome. Congratulations, Brian.
Thank you, sir. Thank you, Dan.
I'm going to go get some water before my next presentation because my throat is getting dry. So give me 2 minutes. I'll be back.
Perfect. Take a screenshot of this. Save that. Save it. X. Go to the next one. 5.5. Should be YouTube. Stop sharing.